So, hello and welcome to lesson 8 in our study of optimization 1. So, in this video, we are going to be introduced to sequential search methods and also go through the 3-point search method. Okay, so far in optimization, we've been learning how to optimize objective functions, and we have so far learned classical methods. By known in practice, locating optimal by calculus is very difficult, and this is because either the objective function is not known analytically so that the differentiation is impossible, or the stationary point cannot be obtained algebraically. So, in such cases, numerical methods are used to approximate the location of local optima to within an acceptable tolerance. So, sequential search starts with a finite interval in which the objective function is presumed unimodal. So, unimodal means it has only one mode. The technique then systematically shrinks the interval around the local optimum until the optimum is confined to within acceptable limits. This shrinking is effected by sequentially evaluating the objective function at selected points and then using the unimodal property to eliminate portions of the current interval. So what this means is that sometimes, depending on the objective function we have, differentiation might be impossible. So that means we can't use the classical methods we know. So in this case, we employ the use of numerical methods. So we always have our solution within a finite interval. Then we keep on reducing the interval until we find the best solution. Okay. So we have various ways of doing this, and we will talk about the following in our study. So we talk about 3-point equal interval search technique, the Fibonacci search method, and the golden ratio or golden mean section search. But in this video, we will talk about the 3-point equal interval search technique. Okay. So the 3-point equal interval search technique. So in a 3-point equal interval search technique, 3 points XL, XM, and XR are equally placed in the interior of the interval A1, B1, and a minimum of, so that's if you are asked to minimize. Okay, if you are asked to maximize, then the maximum. So in a general algorithm, we are going to use minimum. Okay, but if the question tells you to maximize, then it will be maximum. So the minimum of f of xl, f of sm, and f of xr is computed. So this is what we mean. We will have an interval, say a1, b1. Then we will divide this interval into 4 equal parts. Alright? And that means you're going to have 3 interior points. So, there's the first part, second part, third part, and fourth part. And we have 3 interior points, XL, XM, and XR. So this is what the 3-point equal interval search technique does. So with this interval, we will do some computations and we will keep shrinking it, okay, until we get the best solution. So the algorithm. So the procedure is summarized as follows. So when n is equal to 1, that is in our first iteration, we compute ln to be equal to 0.25 times bn minus an. Okay, so this 0.25, right, this is what it means. So our ln is our interval of uncertainty, or the length between the 2 points. So you see, we have a1 and b1. So to find the length between the points in the interval, it to be b1 minus a1 over the number of what equal parts, which is 1, 2, 3, 4, so over 4. So this is the same as 1 over 4 times b1 minus a1. 1 over 4 is the same as 0.25 b1 minus a1. Okay, so that's the reason why when you're finding our length, we always have 0.25 multiplying some bn minus an. So we will compute ln to be this. Alright, after getting our ln, our xl will be an plus ln, our sm will be an plus 2ln, and xr will be an plus 3ln. Okay, alright, so that's step 3. So this is very simple. So we have a1 here. So to get xl, it will be a1 plus the interval here, which will give us this. To get xm, it will be a1 plus twice the length. Now will give us this. And to get xr, it will be a1 plus 3 times the interval. Then if our bn minus an is less than the tolerance given, or if m minus f of an is less than another tolerance, and if m minus the magnitude of m minus f of bn is less than another tolerance again, okay, or if n is equal to n naught, where n naught is some predetermined value or the number of iterations. So that means if we are at our last number of iteration, then we go to step 7. All right, and this is what step 7 says. We stop and we estimate f star by this formula here. Don't worry, as we solve example, you realize that the algorithm is very simple. So that's step 4. So step 5 says, so if that's not the case, then we go to step 5. So step 5, we compute m, and m is equal to the minimum. I told you we are using minimum in the algorithm, but if the question asks you to maximize, it will be max, the maximum. So the minimum of f of xl, f of xm, and f of xr. So if m is equal to f of xl, this, then we let an plus 1 be equal to an. Okay, and bn plus 1 is equal to sm. Okay, so this is how it is. We have the interval, we have an here, bn here, xl, xm, xr. So if m is xl, okay, that means we will take this interval away and we will only be interested in this. So an, we will only consider this interval. So our new an plus 1 will correspond to an, and our bn plus 1 will be what? Sm. So that's what it means. Then after, we go to step 2 and we continue doing our iteration. Then if m is equal to xr, okay, so in this case, if it is xr, then that means we will only be interested in this portion. So now this will be our, and this will be our bn plus 1, right? Okay, and if m is equal to f of xm, then we have this. Then we go to step 2 and we continue doing our iterations. So trust me, the algorithm is very simple. You realize that as we solve an example with it. So we take a question. The question says maximize f of x is equal to x multiplying 3 minus x, then raised to the power 5 over 3 over this interval using the 3-point equal interval search method. And we have to do 5 iterations. So solution. Our objective function is this, and the interval is that. So starting from our first iteration, it means a1 is 0, right? Because a1, this is a1, this is a1, and this is b1. So a1 is 0, b1 is 3. So to get l1, l1 is 0.25, then time b1 minus a1. So we get 0.25, 3 minus 0. And when we compute this, we get 0.75. So that's our L1. We have to compute XL, XM, and XR. So XL is given by E1 plus L1, which is 0 plus 0.75, which gives us this. XM is E1 plus 2L1, which is 0 plus 2 times 0.75, giving us 1.5. And XR is A1 plus 3L1, which gives us 2.25. So the question says we should do 5 iterations. So that means until we get to the 5th iteration, at every point we'll compute f of xl, f of xm, and f of xr. It is when we get to our 5th iteration that we will add the um, exterior points to it. That's a and b. Okay, right. So we have to compute f of xl, f of xm, and f of xr. So f of xl will be f of 0.75. So we go into our objective function. There is it. Wherever you find x, we put 0.75 there. So that will give us 0.75 times 3 minus 0.75 raised to the power 5 over 3. And computing this gives us 2.8975. So f of xm is f of 1.5. And computing that gives us 2.9483. F of xr is the same as f of 2.25. And that gives us 1.3930. So after computing this, our m is equal to the maximum of f of xl, because the question says we should maximize. So that's why it's equal to the maximum, the max. So f of xl, f of xm, f of xr. So making substitution, we have this. So out of these values, which of them is the largest? You can see it is 2.9483, and that corresponds to what? F of what? Xm. So that means our m is equal to f of xm. So since our m is equal to f of xm, that means this is f of xm. Okay, so that means we'll consider f of xm and the 2 points closer to it, so this point and this point, and we discard the rest, so we shrink it. So now our new, when you go to the second iteration, our a2, our new a, which is a2, will be xl, and our new b, which is b2, will be xr. So now let's go to the second iteration. N is equal to 2. So since our m was equal to f of xm when n was equal to 1, then our a2 is equal to xl, which is 0.75, and our b2 is equal to xr, which is 2.25. So we compute l2, and l2 is equal to, so know that we are using everything from the algorithm we discussed earlier. So l2 is equal to 0.25 times b2 minus a2, which is 0.25 times 2.25 minus 0.75. And doing this computation gives us 0.375. So we then have to compute XL, XM, XR. So XL is given by A2 plus what? L2. We are doing the second iteration, that's why it is A2, L2. If you are doing the third iteration, it will be A3, L3. And that will give us this. XM is A2 plus twice of L2, which gives us this. XR is A2 plus 3 times of L2, and that gives us this. So after that, we then have to compute f of XL, f of XM, and f of what? XR. So f of XL is the same as f of 1.125, and that will give us 3.2074. Okay, so f of 1.125 is the same as, when you put inside the objective function, it is 1.125 3 minus 1.125, then power 5/3. Remember, the objective function is f of x equals x 3 minus x power 5/3. Then f of xm, that means wherever you find x, we put 1.5 there. And when we do that, we will get 2.9483. And f of xr will give us 2.2816. Okay, all right. So after getting this, then we have to find the maximum of it. So the maximum of it will be given by f of xl, f of xm, f of xr, and that is 3.2074, right, which corresponds to f of xl. So since that's the maximum, that means we will take what? The 2 points closer towards xl, one to the left, one to the right. That means our new interval now, we'll be interested in this and that. So we discard the whole of what? This portion. So that means our new A3, our new A, which is A3, will be A2, and our new B, which is B3, will be what? XM. So now going into the third iteration, our A3 will be what? Equal to A2, which is 0.75, and our B3 will be equal to XM, which is 1.5. So our L3 will be given by 0.25. We always have 0.25. When we were going through the algorithm, we saw that. Then B3 minus A3. And it is B3, A3 because we had a third iteration. So N is equal to 3. So making substitution, we will have this. And computing this gives us 0.1875. So we now have to find XL, XM, XR. So XL is given by this formula here. And computing that gives us this. XM is given by this formula here. Computing that gives us this. And when you compute XR, we get this. So now we have to compute f of XL, XM, XR, and find the maximum of it. So computing that gives us, so f of XL will be f of 0.9375. So you put 0.9375 in the objective function wherever you find x. That will give you 3.1330. F of xm will give you 3.2075, and f of xr will give you 3.1393. So you can see m is equal to the maximum of these, and that corresponds to 3.2074, which is f of xm, right? Okay, so since that is f of xm, that means we will now be interested in this interval, right? So we discard this, and we also discard this. Sorry. So our new A, which is A4, will be XL, and our new B, which is B4, will be what? XR. So we go to the fourth iteration, and We set A4 to be equal to XL and B4 to be equal to XR. So A4 in this case will be 0.9375 and B4 will be 1.3125. Okay. So we then compute L4, and the L4 is given by 0.25 times B4 minus A4. So making substitution, we will have this, and computing this gives us 0.09375. So we then have to find XL, XM, and XR. So there's the formula for XL. When you make substitution, you get this. Computing XM gives you this, and computing XR gives you that. So we then compute f of XL, f of XM, f of XR. So f of XL is f of 1.03125. Computing that gives you this. F of XM gives you this. And f of XR gives you this. Note that f of XR, which is f of 1.21875, means we're going to the objective function, which is f of x equal to x 3 minus x 5 over 3. Then f of 1.21875 will be, wherever you find it, you put 1.21875. Then 3 minus 1.21875. Then raise to the power 5 over 3. That gives you this. Okay. So we then find the maximum of it. Alright. So the maximum of it will give us 3.2074, which corresponds to f of xm. So that means we have to find E5, B5 and use that for our last iteration, because the question says we should do 5 iteration. So since it is xm, that means we're only interested in what? This interval. So we discard the rest. So our new E, which is E5, is XL. Our new B, which is B5, is XR. So we use that to do the last iteration. That's n equals 5. So our A5 is equal to XL, which is this. And our B5 is equal to XR, which is that. So we compute L5. L5 will be 0.25 times B5 minus A5. Making substitution gives us this. Computing that gives us this. So we then have to compute XL at this iteration. So it will be A5 plus L5, which gives you this. XM will be A5 plus twice L5, which gives us this. And XR will be A5 plus 3 times L5, which gives us this. Alright. So since this is the last iteration, we compute f of XL, f of XM, f of XR, and we add the stereo point to it. That is A5 and F5. So you compute f of A5 and what? F of B5 as well. So computing them, f of A5 will give us 3.1891. F of XL will give us this. F of XM will give us this. F of XR gives us this. And f of B5 gives us this. Right? Or 3.1899. So now that we have these 5 functional values, since the question asks us to maximize, we are supposed to find the maximum of it. So our f star, which is the solution, will be equal to the maximum of these 5 functional values. So you can see the largest here is what? 3.2074. Is it 3.2072? Sorry, you can see from here we have it here coming 3.2072. So 3.2072. So the maximum of it will be 3.2072, which corresponds to what? F of what? Xm. So hence the maximum value is what? 3.2072, and it occurs at the what? The point Xm, and Xm in this case was what? 1.1340625. So using the 3-point equal search method, we've been able to maximize that particular function over the interval which was given to us. Okay, so do all to go through the iterative process yourself and compute the values yourself and compare them. Okay, if you find anything different, try to compare them with others so that you get the right one. Okay, so thank you very much, and see you in the next video. So the next video will be on the Fibonacci search method. Okay, so thank you.